let's get started with this session today. And thanks everybody who has joined online to hear me talk about this session. Okay, it's really feel great looking at the participation today. Okay, so let me get started. I'll first quickly cover the agenda for today or the topics that I'll be covering today. Right. So we'll start a bit about data warehouse. We'll just briefly discuss what data warehouse is, and we'll also briefly talk about business intelligence. Right. Using that information, we'll try to dig into what data modeling is, and we'll talk about its important and benefits. Right. Later, we'll discuss about some types of data model and the process that we go around while performing data modeling, right? And most importantly, we'll look at data modeling in action for one of the use cases. Okay. Lastly, we'll basically talk about some best practices around data modeling, which one should look out for. Okay. So time check. So we are around 8:40. So I think that we'll be able to complete this within 1 hour, and then for the time that we would have remaining, we'll look at different questions and try to answer this. Okay. So before I start, already there has been an introduction of myself, so I'll not take much time, right? So myself, Ankit, so I'm a data enthusiast. This is the first thing I always tell anybody about myself, because that is one of the core adjective about me, right? I carry about 9 years of experience entirely working on data projects. Currently, I'm working as a data engineering lead at Jet2 Travel Technologies, which is in Pune, right? I've played multiple roles, from tester role to developer to data engineer, data architect, scrum master, product owner, and all those kind of roles. And most importantly, being a team member, that I feel that's the most important part of any job, right? I've worked on multiple enterprise data platforms pertaining to banking domain, insurance domain, telecom, retail, and travel domains recently, right? Currently, I specialize on building cloud data platform for data engineering, warehousing, and data science workloads, predominantly on Snowflake Cloud Data Warehouse alongside AWS and GCP Cloud Platform Services. Okay, my LinkedIn profile is already shared on the chat. So if somebody wants to connect with me to talk about different aspects of data or about the session, right? If I'm not able to answer any question, we can discuss over LinkedIn. Okay. So let's get started. So first thing, what is data warehouse, right? That's the first thing that comes to the slide, right? So data warehouse, we can think of two parts, right? One is data and one is warehouse, right? So if we try to look at individually what each of these words mean, right? And we try to see the properties of each of these words. So data is essentially nothing but facts that your business process applications are generating, right? It comes in varied data formats. It could be structured, it could be semi-structured, or even it could be unstructured, right? It represents an actual fact, an event, a value, right? And also it represents peripheral information about the fact, the event, and the unit of the value, right? It's written in different terminologies in different systems, right? Some system might classify gender as M or F, right? Some systems might classify gender as male and female, right? So it can be different terminology depending on the system, right? Since there are different system involved, so there is always a different frequency at which the data arrives in any platform, right? When we talk about warehouse, right? Warehouse, just in layman language, what warehouse is, right? You might think of an Amazon warehouse or Flipkart warehouse. What is a warehouse supposed to do, right? It's a storage location essentially, right? Or you can call it as an inventory assembly point, right? It's able to stage products or inventory whenever basically the truck comes in with load of packages. It is able to have an area to stage that package, unload the data, right? Unload the packages, and also place them into the warehouse, right? It is able to logically segregate or collate, or importantly, keep the inventory or the product safe, right? it's able to translate different terminology products under one unified categorization, right? Noodles could come in different names and versions, right? But is able to categorize it as food item, right? Now, it is also able to distinguish racks or set of racks based on the category, right? And essentially, it's also able to provide in-depth visibility on the inventory utilization or number of products available, right? So that's a layman version of what warehouse is, right? But when we combine data and warehouse as data warehouse, right? The data warehouse becomes a storage unit for your enterprise data, right? Where the data warehouse is able to stage incoming incremental data, right? Load into structured format into tables and columns, right? Logically segregate different subject area data, integrate different data coming from different sources into one common terminology. And obviously, it's able to derive insights using business intelligence and other reporting tool, right? So that's how we can think of data warehouse. So I have a pretty description of what data warehouse is, right? So data warehouse is a single place for all your enterprise data, right? You can say that it's a single source of truth because it is governed. When I say governed, it means that obviously it has gone through a lot of data quality checks, right? Now, data is ingested from different sources via ETL processes or ELT process, right? ETL is nothing but extract, transform, load. ELT is another variant of data load pattern, which is extract, load, and transform, right? Now, data which is coming into your data warehouse is transformed as per your business requirements. It modeled for best performance and storage optimization, and is always available for predefined and ad hoc reporting analytic needs. Right, that's what a data warehouse is. So the diagram that you see here is a very common representation of a data warehouse in any enterprise that you will find, wherein you'll have multiple data sources, right, which are basically sending out different data files. You'll have a staging area, which is basically responsible for unloading or consuming the raw data files which are coming from different data sources, right? You will have a ELT pattern or a ETL pattern for data transformation, which basically moves your raw data into model data after applying business rules for transformation, right? And also along with the data warehouse, you'll find data marts created, which are basically subject-oriented data store, where you'll generally find like aggregates or summary tables or custom rule-based views, which are basically dedicated for a specific subject area, which could be finance, retail, or sales, or could be operations, right? Now, once you have this data within your data warehouse, right, obviously the data without analyzing it doesn't have any value, right? So you have to analyze the data that you have stored in your data warehouse via BI tools or reporting tools or other applications that you have within your business, right? So the data warehouse basically delivers the starry insights which your business users require via BI tool through graphical representation of your data or via different reporting tools, right? Now, when we talk about the data warehouse, right, it's essential to talk about the characteristics of a data warehouse, right? Somebody might ask you that, okay, it's a data warehouse, it's just another database, right? What's the difference between a database and a data warehouse, right? So it's very important to know that a data warehouse has 4 essential characteristics which defines it's as a data platform, right? One is it's being subject oriented, right? Now, when I say subject oriented, it means that the process or the data revolve around a theme rather than the direct business process. Example could be sales or marketing or distribution and many more, right? It's time variant. It means that the data that is stored has an associated time portion, which helps us in analyzing the historical data trends, right? It's non-volatile, which is related to being time variant, which means that whenever any new data points are stored in the data warehouse, right, the previous data is not removed or affected in any way. It means, in simple terms, once you have data within your data warehouse, it's not deleted or removed or updated, right? Subject to obviously data archival strategy, which basically removes very outdated data within your data warehouse. Okay. Lastly, uh, fourth characteristics of a data warehouse would be integrated. Now, multiple data sources are feeding similar data, which needs to be integrated and transformed in a common terminology for better understanding. Like we saw the example of gender, right? If one application stores gender as M or F, right, and the other application stores gender as male and female, right? It's important to uh, bring those data values in a common terminologies for ease of handling and analysis within the warehouse. Now we talked about data warehouse for a bit, right? Let's see what business intelligence means, right? We'll not dig deep into it, right? But essentially, what business intelligence is, it's basically getting the right data in the right format at the right frequency and time to the right consumers with the right data quality powered by the underneath data warehouse, right? Now, don't think business intelligence as some big artificial intelligence kind of system. No, it's basically deriving insights of out of the data which is present in your data warehouse via visual depiction of your data through graphs, reports, right? So that somebody who is consuming the data looks at the graph or looks at the report, right, and is able to perform better decision making based on the visual representation of data, right? So if we try to call out some of the aspects of business intelligence, right, it's basically to improve the decision making process within an organization, right? It makes it easy to access and share information within your organization, right? It enables real-time analysis for quick navigation, helps identify waste in the system, reduces the risk of bottlenecks, and helps you know your business better, right? So take, for example, let's suppose you are building a sales data warehouse, right? When we say sales data warehouse, you have maybe a website or a shop where you are selling products, right? Now, within your data warehouse, you're capturing all your sales information, and the business user wants to track the revenue generated across different cities, across different products, right? And they want to react whenever they see that the revenue is dipping for a specific product in a specific area, right? So using visual depiction of that data would let them react to such cases and obviously make alternative decisions so that they can improve the revenue in that specific product or a specific area. Okay, so that's the basic gist about business intelligence, right? Now let's try to see what data modeling is, right? Is it just data doing a ramp walk for a fashion show? No, it's not. So data modeling, essentially, yeah, you could imagine that data is essentially modeling, and you basically represent a beautiful version of your business process via a data model. So essentially, it's kind of related to data being part of a fashion show, but no, essentially, it's not, right? So let's see what data modeling is, right? Now, data modeling is the process of basically analyzing or so basically data modeling is the process of analyzing and understanding your business processes, the data that your business is generating, producing, as well as consuming, and is also utilized to depict the relationship between those bits of data. Right now, data modeling allows you to create a visual description of your business by analyzing, understanding, and clarifying your data requirements, how they underpin your business process. Right. Generally, you would see data model is depicted via entity relationship diagram. We'll look at what entity ERD diagrams are in the coming slides. But yeah, that's one of the most common way of depicting how a data model is, right? So if you look at the picture here, right, imagine that a user or a person has a lot of clothes, right? But his cupboard looks like the left hand side, right? With every other clothes scattered in, right? He is not able to decide as to which clothes to pick up, right? How to find the matching clothes, how to find the matching shirts with the matching jeans, right? And maybe there are some clothes which remain burden under the other and never are found, right? So he's very confused as to how he decide the outfit of his day, right? But on the right hand side, the person has good amount of clothes and has it very much organized, structured, right? He has different cabinets for different sort of attire. He has one cabinet for shirts, or one cabinet for blazers, one for maybe shoes, right? So it's very much sorted, it's very much organized, logically separated out, right? Related things set next to each other, right? So that person is very easily able to decide what outfit he can try out for that specific day, right? So essentially the same thing is related to data modeling in an enterprise, wherein imagine that you have an enterprise and you have data coming from many different sources, right? You're directly continuously dumping the data in different tables without thinking about the relationship between the data, right? So you'll have a database with hundreds of table, right? And not knowing how one table is related to another, right? But if you do proper data modeling, right, you understand the relationship between different tables, you logically separate out different tables and columns, you perform normalization and all to break down tables into different chunks, so that you reduce data redundancy, right? Essentially, you are optimizing your storage utilization, so you'll have a better version of your data warehouse where you'll be able to easily perform analytical operations, right? Like you see in the right hand side of the image, right? So essentially, data model is a simplified view of reality that captures the most important aspect of your business. How accurate it is depends on the artist, that is the data architect or the data modeler, right? So it's very important that that a data architect or a data modeler or whosoever is basically building your data model looks at the data at a very broader point of view and basically tries to optimize how data is stored in your data warehouse. Now, essentially, when we say data modeling is a technique or is a job which specific individuals only perform, like a data architect or data modeler, it's essentially not that necessary for data architects or data modelers only to do this job. Anybody who has the business understanding, who understands their business processes, who understand the data, right, can perform data modeling. Essentially, in this modern day of development, right, developers and testers can also contribute toward data modeling. Developers can basically try to build model. Obviously, there could be a governance layer to validate that model, and the testers can try to see if that model truly depicts the business process and is basically optimized or no, right? So essentially, there is what I'm trying to say is there is no specific coding skill or tool knowledge you require to perform data modeling. The key thing that you should know is you should understand your business end to end. You should understand your data. You should be really good at profiling or going through the data, right? And anybody can perform data modeling irrespective of the tag job role. Now let's get into as to why data modeling is important, right? We touched base about this a bit in the previous slides, but let's talk more, right? Now, data modeling, we know, is the process of transforming data into information, right? Now, any information is useless unless it is delivered in a format that can be consumed by a business user. So imagine I tell you that I had a burger recently, which was really good, right? As somebody who is listening to this, right, is that information useful to him? Because he doesn't know from where I ate it, right? At what time did I order at home, or did I go out there, right? What type of burger it was, right? So unless that information is in the better format, right, it can't be consumed by any user, be it a general person or a business user in an enterprise, right? And data modeling helps in translating the requirements of these business users into a data model that can be used to support business process and scale analytics, right? So it's very important for a data modeler to have in constant touch with the business user so that the data modeler models your data warehouse for the business user, not for himself, right? So when we talk about a good data model, right? So what all attributes or what all questions it should be able to answer, right? First and foremost, obviously, a data model should be able to answer what our business process is, right? How do we structure our business information into the data model, right? What kind of information do we use with these processes, right? What kind of information actually we store, and from where does it come from and where does it go? So it's very important that uh, the data that we are storing, we are actually preparing a data dictionary which tells about the different categories or different attributes about the data, right? We have a data lineage which tells me that from where the data has come through what level of transformations, right? And essentially where the data is going, who is consuming it, how is consuming it, to better understand the processes and better model the data, right? Now, data modeling essentially is a very important stage of any software project, because without it, you cannot get a clear idea of what your database should look like and how your application be built upon it, right? So these are some of the points that I wanted to talk about as to why data modeling is important. I have few more items to discuss about, let's say, the benefits essentially for about data modeling. So when we talk about benefits, right? So with having a good data model, right, you have a higher data quality. Now imagine when somebody is building a constructing a building, right? Now, if that person doesn't have a blueprint about that building, right, they'll end up with something which is not usable or something that might fall to the ground, right? It is possible, right? So similar case, right? When you're building an analytical platform or a data warehouse, right, it's important to have a data model in place so that you know what you are trying to achieve and how it would be done, right? Essentially, linked to that, obviously it cut cost and achieve faster time to value. Obviously, if you plan well, right, about how your data model should look, how your data should be stored, right, you'll be able to cut a lot of cost which might come through late defects which might come during development, right, or testing, or essentially maybe while the business is using the analytical platform. So data modeling typically generally consumes very less percentage of project budget, maybe 5 to 10% of project budget, but it has a lot of impact through the entire life cycle of the project. Okay. Now, it also helps benefit faster performance, right? So data modeling isn't just about saving money. That's really important. But the real value of data modeling is that it makes your application run faster and more efficiently. Now, how it makes it run faster? By having the data stored in the most data redundant, non-data redundant way, right? Having the relationship set in a very optimized way so that data ingestion and data retrieval is very much fast and easy within your analytical platform. So it helps you derive faster performance so that you can get data easily in and also get data out easily. Then there are other benefits also in terms of understanding and improving your business process, right? While you are working on the data modeling exercise, right, you are trying to basically go through the entire documentation that you might find about a business process, or you might be doing a lot of data profiling, right? In that way, you are basically encouraging people to identify maybe a possible gap in the business process. And also when every individual developer, tester, and other team members are involved in data modeling, right, you are actually enhancing the collaboration within your team, right? So each individual in the team would know better the business process that are currently existing in your enterprise. Okay. And obviously, you end up having a better documentation for your long-term maintenance, right? So data models help to define the business process and the interrelationships, right? So if all the data related to a business process defined in a single place, right, it becomes easy for somebody to understand and maintain those processes long term. Imagine a new group of members have come into your organization, right, and they have no idea about the data model. They'll struggle a lot, right? But if you have a pre-documented data model, it helps anybody understand in a very better way as to how data is flowing within the organization and how data tables are related to one another. If somebody is tasked to enhance a specific table or enhance a specific data flow, right? So better documentation obviously helps the upcoming members and obviously helps you maintain your data model in the longer term. Okay. So how does a data model look like? So this is a very common or a very simple representation of how a data model might look like. You will have different entities. You will have relationship between entities. It could be one-to-one relation. It could be one-to-many relation, right? Within the entities, you will have different column setup, having a specific data type associated, specifying if it's nullable or not null, right? You'll have primary keys, you'll have foreign keys, right? Primary keys are basically keys which uniquely identify your data. Foreign keys are basically defining the relationship between parent and child table, right? So this is a basic representation of what a data model looks like, right? It's again a ERD diagram, entity relationship diagram. Okay, it's just placed here for somebody who might have not seen a data model before to see how it actually looks like, right? Now, unfortunately, some of you or I have seen this kind of data model, which is a jungle of entities and relationships going from here and there. Every other table seems to be related, right? This is a really worst place to be in, right? For any architect or data modeler or any developers also, right? So this is one of the kind of data model that some enterprises end up having, right? So we talked about the good data model, right? So it's one thing creating a good data model. It's another thing is maintaining it to be good with the future changes coming in, right? So it's very important. So data modeling is not just essentially practice or an exercise that's done at the start of the project. It's a practice or an exercise that should continue along with every other change that happens within your business process or application, or you will end up with a jungle like this. So just be cautious about when you are modeling. It's very important to see what is there existing, right, and how you need to evolve your data model for upcoming changes that are happening within your business. Okay. Now let's talk about one of the very common kind of data modeling technique that is very much prevalent in many industries, right, which is called dimensional data modeling. So it's a technique to design and organize data, obviously, in your database for effective querying and reporting. It's very much commonly used in data warehousing and business intelligence systems, right? Now, the basic building blocks of a dimensional data model are: you have a fact table. Now, fact table is a table which contains fact or measures or value, which are basically very much a core part of your business, right? Uh, those values or measures are stored against the grain of the table. A grain is basically, if you can think of something that you are measuring your value or let's say for a sales fact table, right? You are measuring amount against specific attributes or specific variables like product or customer or basically store, right? Dimension tables, on the other hand, are tables which stores the who, what, when, and where of each of these business processes which your fact table holds, right? It basically provides meaning to the fact, right? So in the example that you see on the slide, you have a retail sales fact table, right, which has quantity and sale amount, right? So these are the measures which the business is trying to basically quantify in this dimensional model, right? Now, what dimensions provide value to these quantity? So you want to measure the sum of quantity, let's say, over product, right? So product is a dimension which provides value to your analytics when you do a summation of amount across product, right? So dimension are basically keys or variables which define your measure, right? Now, there are multiple kind of schemas which are created within dimensional modeling. One is called star schema, one is called snowflake schema, there is one more called galaxy schema, but let's stick to star and snowflake, right? So star schema is basically a very common dimensional modeling schema wherein you have one fact table surrounded by multiple dimension tables which are denormalized in nature, right? When I say denormalized in nature, so there is a concept of normalization versus denormalization. I've not included that within the session because it would extend a lot uh, to be completed within 1 hour. But normalization, if I talk in a very basic way, it's a process or a technique to break tables into multiple tables to basically reduce data redundancy, as in duplication of data, right? And denormalization is basically stating that data can reside in one table even if there is data duplicacy, right? Snowflake schema is an extension of star schema, right? Where the dimensions that surrounds fact table are basically normalized, wherein broken down to basically reduce data redundancy, right? The image that you see here on the slide is an example of a star schema where there is one fact and then several dimensions like customer dimension, store dimension, product dimension, date, employee dimension surrounding the fact table, right? Now, you would notice the fact table essentially contains measure and there are several keys. So basically, these are foreign keys to the specific primary keys of the dimension table. So you'll have customer key within the retail sales fact table, which essentially is the primary key of the customer dimension table. So that's how the facts and dimensions are linked. So whenever you are doing some analytics, right, you will join these two tables on these key attributes and do some aggregates as per your business needs. Now let's try to see different types of data model that exist in practice today. So essentially, these are ideal kind of data models that you'll try to create when working on a data modeling exercise. I personally don't feel that all of these are required essentially, but this is the ideal way to go through a data modeling exercise. So firstly, we start with a conceptual model, which basically identifies the business concepts. It's a very high level depiction of how your business process is and what would be your high level entities, right? Then we have the logical model, right? Logical model has a lot of granular details about the entities that you defined in your conceptual model, with all of attributes identified and how the entities are related to each other via relationships, right? Then comes the physical data model, which is nothing but the actual database implementation version of your data model, of your logical data model. So let's try to see with example what these different types of models are, right? It would be better to understand them. Okay. So conceptual data model, like I said, it identifies the highest level of relationship between different entities. These are very high level entities, and only the most important entities and relationship between them are captured. There are no attributes specified, but it's not restricted for that conceptual data model. And you don't have obviously the database implementation level details. So you see in the diagram, right, if we imagine a order kind of business process, you will have a customer who is buying a product and you will have a product entity which is being sold out, right? And the relationship between these two entities are the customer is essentially buying the product and the product is being sold, right? Now there could be other entities involved here which are dimensional entities, right? A customer might have an associated address and he might have different addresses associated with him, a home address or office address or temporary address, right? So these are some high level entities you might think of it for an ordering system, right? So that's where what goes into the conceptual data model. When we dig deep into the logical data model, right? The logical data model describes the data in as much detail as possible without regard to how they will be physically implemented in the database, right? Now, it includes all the entities and the relationship. It it basically adds all the attributes for each of the entities. The primary keys are defined, foreign keys are defined, and also essentially you would perform normalization also while performing logical data modeling, right? So if you see in the picture depicted here, earlier you saw just customer entity and product entity. Now you have the attributes defined, their data type defined, the relationship defined, right? And when we go into the physical data model, essentially it's the actual, possibly you can think of a DDL, right? Which would be actually implemented on your data warehouse platform, right? Essentially, when we go about data modeling, right, it's very important to start with conceptual data model, and obviously it's very key to build the logical data model. Physical data model you can create because or you can even avoid unless you are directly going to implement. But logical data model is really important because let's suppose tomorrow your data platform changes from one DBMS system to another, right? You might not be able to translate the physical data model into the new DBMS platform, but you'll be easily able to translate the logical data model as per the new DBBMS requirement. Okay. Now, on a high level, if I try to compare what all attributes or what all things go into these three different data models: conceptual, logical, and physical. Conceptual only have your highest level entity names. It's high level entity relationships. Logical would have additionally attributes, primary key, foreign keys defined, and physical would additionally have the actual table names, actual column names, and the actual data types. Now, let's try to see the general steps for data modeling exercise, right? You start with identifying the entities or the business objects that are represented in the data set being modeled, right? It's kind of the conceptual data modeling exercise, right? You identify key property for each entity so you can differentiate between them in the data model. Again, kind of conceptual data modeling exercise. You draw a rough draft of an entity relationship model to show the connections between the entity, right? You identify the various data attributes that needs to be incorporated in the data model. This is kind of logical data model exercise, right? You map the attributes to entities so that the model properly reflects the business meaning of the data, right? And then finally, you have the data model finalized, validated, right? And obviously implemented in your data warehousing system. So these are very general steps, right? But essentially the key core steps would be start with conceptual data model, start with business understanding, see how the data is being related, right? And then start to slowly build up the logical data model by identifying the attributes which could exist in the entity and how you can better normalize it or denormalize it based on your needs. Now, quickly, we'll go into a data modeling exercise. We have 15 minutes, 20 minutes remaining, so we'll be able to finish this. So as part of this data modeling exercise, right, I'll take into consideration the Netflix business model. So I believe that everybody has used Netflix and they spend time on Netflix watching some TV shows or movies, right? So everybody knows the business model, right? It's a subscription-based model where customers pay a monthly fee to access the TV shows and movies, right? Now, let's say the Netflix business users wants to build a dimensional data model which helps them on below business problems. So they want to do subscriber analysis, wherein they want to analyze the subscriber data to understand the subscriber demographics, their subscription type, and their engagement levels. They want to do streaming analysis, right, wherein they want to understand what is their most popular content, right, and the time of the day when the most popular content are streamed, right? And they also want to do device analysis, right? They want to analyze the device data to understand what devices are most commonly used by the consumers, right? So these are some of the business analytics that they want to do, right? So if we think for a minute, right, what is that we are understanding from their business process, right? So there is a subscriber, there is content, right? There are devices, there is time, right? And possibly location, right? Which are essentially the core entities, right? So let's try to build a conceptual data model around this information that we have seen right now, and let's see how it would look like, right? Now, I said there would be the core entity would be the subscriber, right, who is watching Netflix. Then there would be content, right? Then there would be device. Then there would be location. Then there would be time, right? Now, these are the high level entities that I can think for a conceptual data model when building for Netflix, right? Now, I also want to see the high level relationships, right? So a subscriber watches content, right? A subscriber watches content using a specific device. A subscriber watches content using a device at a specific time. And also a subscriber might be watching that specific content from a specific location, right? So this gives me a brief description about the business process and how my entities are basically present in the system and how they're interacting. Now, if we try to think from the analytics point of view, what all things Netflix wanted to capture, right? It wanted to do subscriber analysis. It wanted to do streaming analysis, right? Subscriber analysis on the subscriber demographics, subscription type, engagement level, streaming analysis on the popular content, time of the day, right? So if we can try to find out different attributes that might be required while building those entities, right? So let's try to look at the logical data model here for the specific use case. So this is a kind of logical data model that we can build, right? We might have a fact table, right? So it's a star schema dimensional model, right? We have a fact table having several foreign keys to different dimension tables like subscriber key, content key, location, time, device key, and I have some measures captured. The measures are streamed hours, right? The amount of hours a specific customer uh, streaming on Netflix, right? Watch percentage, the amount of percentage that the customer watched for that specific TV show or movie, right? And the idle time to see if the customer just paused the Netflix streaming and was doing something else, right? And then you can define a different dimension tables around this fact, like subscriber dimension, which talks about the subscriber type, his age, gender, right? Payment method, content dimension, which can describe the title of the content, the genre, right? The release date, device dimension, which could be the device name, the operating system, right? Time dimension, obviously the part of day, hour of day, month, right? And location, obviously city, state, zip code, and country, right? So if you think from this data model perspective, does it help the business analytics that the business users wanted to do, right? Which was the business case, right? So if we try to see, right, if we try to do subscriber analysis, right? So I can write a simple SQL query joining the fact table and the subscriber dimension, right? Aggregate the streamed hours across subscriber type to see what kind of subscribers are watching Netflix most of the time, right? And how much time do they spend streaming content on Netflix, right? I can do streaming analysis using this model, wherein I can join the fact table again with the content dimension table, right? And I can basically do a sum of streamed hours against genre to see what kind of genre content is being watched the most, right? If I have to add on more analysis to it, right, I can club subscription fact, subscriber dim, content dim, right? I can do a sum of streamed hours over genre, subscriber type, or maybe age, right? To see if there is any trend found across different age groups of people, right? Possibly there could be specific genre of movies which a lot of young folks are watching, and some could be movies that people in their middle age groups are watching, right? We can do device analysis very easily using device analysis using this model very easily. If I want to see what is the device which is most commonly used while watching Netflix, and what is the time of the day or the hour of the day while people mostly enjoy watching Netflix, right? So that kind of analysis also is very much easily possible using the data model, right? Again, using these dimensional attributes, which are essentially additionally present in this model, you can do a lot of trend analysis to depict how you can improve your product, right? How you can better market your product in terms of Netflix, right? It's very important for them to understand what is the customer wanting to watch next, right? So it's very important that data is well modeled in this kind of model, so that they are able to derive the value out of it, and obviously build their product and obviously enhance their business, right? So that's one of the example I took. I thought that maybe a lot of people might be familiar with Netflix, so I thought that I'll use this as an example to perform a data modeling exercise, right? But obviously, uh, that's not the end to data modeling. There are a lot many factors associated, from normalization, denormalization. There are other modeling techniques as well, not just dimensional modeling. There's data vault, data mesh. So there are a lot of things which are present. But yeah, for somebody who wants to start data modeling afresh, this is something that you should know, right? Lastly, I wanted to cover some bits about the best practices around data modeling. So these are not just the exhaustive list of best practices, right? Obviously, while anybody works on data modeling, right, they might face particular kind of scenarios which works best for them, right? So I'll be happy to know if you have something to share here here on this forum or offline through LinkedIn, right? I'll be happy to hear from you, right? So if I talk about the ones that I've listed here, now it's very important for you to know your application, right? I've said it before also. It's very important for you to understand all possible data scenario, how the data is flowing, right? It's very important to perform data profiling continuously to understand the data trends, the data relationships, right? It's very important for somebody who is modeling a fact table, right, to spend time on defining the grain of the fact table, right? So obviously it's always recommended to have the fact table at the most granular level, so that tomorrow if there is a change in grain, right, you don't need to reload the data within your fact table, right? The basic fundamental thing that somebody who's starting data modeling should do is start with a simple data modeling, simple data model, start with a simple conceptual data model, and gradually and slowly build your logical data model. Don't try to overcomplicate things by putting every other entity in your conceptual data model and try to link each of them together, right? Now, again, one of the key aspect is you need to keep your objective clear in your mind, right? So it's not that you are building the data model for yourself. You are building the data model for the business users or the business analytics capability that needs to be derived out of it, right? So it's always beneficial to always keep that objective in mind, right? Now, you should also keep minimal business rules within the base model, right? You should not apply custom rules and all within the facts and dimension that you're building. Apply those custom rules or business rules at the data mart level, right? Because that is supposed to hold a specific subject oriented data, right? If you apply the business rules and custom rules on the base fact and dimensions, right, then it might not represent a clear picture or a enterprise wide picture for all kind of business processes like sales, marketing, finance, right? You should perform a good judgment of keeping tables denormalized or normalizing it, right? So it's not essentially true to say that normalizing the tables to the extreme ends is the best technique. No, you have to measure the benefits of reducing data redundancy versus the level of complexity you are adding by adding more tables and joins when deriving or retrieving data out of your data model. So it's very important to do a good judgment between these two, right? You should follow standard naming conventions and data type assignments, right? You should adhere to primary key and foreign key usage, right? Use surrogate key instead of natural keys based on specific uses. Yeah. If somebody doesn't know what surrogate key is, it's basically essentially an artificially generated key which uniquely identified is required in your table, right? And obviously you should perform data lineage, document the source, lineage, and the transformation of the data to ensure transparency and traceability. It really helps anybody if there is a proper data lineage process enabled right within your data warehousing platform. It really helps the backtracking of issues, and if there is any data issue or anomaly reported by the business users. So that's pretty much that I wanted to cover. So we are about time also. I hope so basically the basic idea behind the session was to keep it very simple, keep it very basic, right? So that people across different experiences would be able to relate to it, right? But yeah, if you have any questions, feel free to post it on the Q&A section. I'll try to answer as much as possible.
Sir, sorry to interrupt, sir. So,
Yeah.
before we proceed to answer your question, audience, I would like to request the attendees to please fill in the poll about the feedback, as it helps us to conduct more such sessions. So, sir, we have one question from Aisha. Does this mean one need SQL to do data modeling?
Essentially, SQL is a tool or the technology that everybody should be knowing who is working on the data field, right? But essentially it's not per se required, right, when you start with a conceptual data model or a logical data model. But yeah, it's essential for you to know what are tables, what are columns, right, what are data types for a, and what are different data types, what are constraints, right? These aspects you should definitely know, right? But I would say that yeah, if you are doing data modeling, obviously you should know basic SQL so that you can validate your data model that you are creating. And like I said, this was a session where things were kept very basic. If anybody of you has a very specific question, right, do connect with me on LinkedIn and I'll be able to talk through there. So there is one more question: Python or SQL, which helps the most in model building? Now, if you're referring to data modeling in a data warehouse, right? So like I said, it's more of a logical thinking. SQL is something that you should know, right? But if you're referring to a ML model, then I feel that you're referring to the ML model. So then obviously Python would be required there. Okay. So yes, if you are aspiring to become a data scientist, right, obviously you need to know coding skills in terms of Python skills, in terms of SQL skills, in terms of database skills, right? And then obviously if you get into machine learning and stuff, there are a lot many things there that you'll have to code and practice out. But yeah, it's a great field to catch up. I don't see any more questions here on the board. So I think we can wrap up. And again, like I said, if you want to connect, feel free to connect me on LinkedIn and send me a hi. We'll start a conversation there. Okay, guys, thank you so much. Thanks for attending this. Really appreciate it. Thank you. Bye.